All right, today we're going to talk about combinations. So there's two types of probability that we generally talk about, which is combinations and permutations. So we've already spoken about permutations. Permutations is when the order matters, when you're lining things up, when you're putting things on a shelf, when you are electing officers. But a combination is a selection of objects without regard to order. So for instance, if I deal you a hand of 5 different cards, those 5 cards are going to be in your hand in any numbers of ways. You could put them in your hand this way, or this way, or this way. The order does not matter. It's still a 5-card hand. So let's go back to Mickey, Papa Smurf, and Tweety. How many combinations of these 3 are there? So I think of combinations almost as like a group. So another way to kind of ask this question is, how many groups can I make out of these, groups of 3 can I make out of these 3 characters? Well, just 1. But if I asked, how many groups can I make of 2 of the 3? Well, then you think, I could have Mickey Papa, I could have Mickey Tweety, and I could have Papa Tweety. But that's it. So there's half as many combinations as permutations in this case. So figure out how many permutations there are, and then divide by the factorial of the number you are choosing. So if I have 1, 2, 3, 4, 5, 6, 7 characters here, and I said how many combinations of 3 are there? Well, first let's figure out how many permutations of 3 there would be. Well, that would be 7p3. And then I'm going to divide by the factorial of how many I'm taking, so 3 factorial, or 35. So the formula that you are using is very similar to the permutation formula, except that instead of having in the denominator simply n minus r factorial, you also have to multiply by this r factorial. And it is represented by NCR instead of NPR. So the number of combinations of 52 cards taking 5 at a time is 52 factorial divided by 5 factorial, that's how many we are taking, and 47 factorial, again, that's sort of like the number of rejects, the numbers we are not taking. But this is done much more easily on your calculator. Instead of going through the formula every time, it's just most commonly just put in your calculator. And very similar to the permutation, you're going to go to math, probability, and instead of going to 2, you're going to go to 3, which is NCR. So how many 5-card hands can be dealt that meet the following conditions? All 5 are hearts. So you first have to think about, well, how many hearts are in a deck? Well, there's 13 hearts, and I want 5 of them. So this will be 13C5. Put that in your calculator, you'll get 1,287. 2 are hearts and 3 are hearts. So remember, we talked about if you have the word and, you're going to multiply the probability or the numbers together. And if you are going to have an or, you're going to add them. So I want 2 hearts. So there are 13 hearts in a deck. I want 2 of them. So that would be 13C2. There are 3 clubs that I'd like, so 13C3. And I'm going to have to multiply those 2 numbers together. If I want all the same suit, so I have to think, all right, I would like to have either 5 hearts or 5 spades or 5 clubs or 5 diamonds. That's how I can get all in the same suit. So now I have the word or, so I'm going to have to add all of these together. Well, the way I can get 13 hearts would be there's 5 hearts. There's 13 hearts in a deck, and I want 5 of them. There are 13 spades in a deck, and I want 5 of them, and so forth. So I'm going to have 13C5, and I'm going to add these probabilities together. Another way to express this is just 4 times 13C5. And what about if I want at least one of each suit? So I would like to have one heart, one spade, one club, one diamond, and one anything else. I don't care what it is. Well, the way I would get one of each suit would be 13C1 times 13C1 times 13C1 times 13C1. That would give me one heart, one spade, one club, one diamond. But for the last one, I don't care what it is. It can be anything. But I've already picked 4 cards out of the deck. So it would be 48C1. Again, I'm going to multiply these together because I want them all at the same time. What about if I want all face cards? Well, face cards in a deck are cards that actually have a face on them. So King, Queen, Jack, those are your only face cards. We do not consider aces a face card. So there are 3 in each suit. There are 4 suits, so there would be 12 face cards. If I'm going to pick 5 cards, it would be 12C5. And what about if I want no face cards? Well, this would just be the opposite of that. There's 12 face cards in a deck, then you know there are 40 non-face cards, so 40C5. So when you're thinking about whether a question is a permutation or a combination, you really have to think, does the order matter? Am I lining them up or am I just taking a group? If you have any questions, please let me know.